Hey there, you it's Mr. Herman here, and this is the first video for a new topic of algebra. And here, chapter 5a, we're going to be looking at the language of algebra. The learning intentions is to know the basic terminology of algebra, and this criteria is to be able to identify coefficients, terms, and constant terms with expressions, including in situations where coefficients are 0 or negative, and to also be able to write expressions from word descriptions. Now there's going to be a lot of new terminology that will be introduced to you that you may or may have not seen within year 7. Don't feel too intimidated by this nor the topic of algebra. I know that some students might find this topic quite scary because there are letters involved with numbers, but we'll just be looking into the basics of how algebra works, and then from there we can build up our knowledge and skills of this what seems to be scary topic. So a pronumeral is a letter that can represent one or more numbers. For instance, we usually use the letter X. Don't ask me where it's come from or why we use it. The X could represent the number of goals a particular soccer player scored last year. Or P could represent the price in dollars of a book. The word variable is also used to describe a letter which represents an unknown value or quantity. I like to think of letters or pronumerals used in algebra as letters that will eventually be replaced with numbers. If we don't know what a certain number is, we use a letter in its place. Okay, now this obviously will make sense when we apply this to real life context. The only thing about this is that once we start using letters within the world of maths, we have to come up with certain rules and characteristics that follow with this in order for everyone to be on the same page. Okay, and there's quite a few rules that follow, but you can use this as a guideline to tackle your questions within exercise 5a. So let's go through these key ideas. In algebra, letters can be used to represent one or more numbers. These letters are called either pronumerals or variables. Generally, when you're looking into algebra in primary school, teachers tend to use the word letters, but the formal name is pronumerals or variables. This second dot point here, A, X, B, this is just saying that A times B. We don't know what A is, we don't know what B is, it's just two random letters. Another way of writing this is putting the A and B together. And the reason why we do this is that the multiplication sign can get confused with the letter X, which we use quite a bit. So to make things easier, whenever you see two letters next to each other, they just simply mean it is A times B. And when A is divided by B, we don't usually see this division symbol in maths. If we do, it's a bit informal. How you should write this is A divided by B. A times A, this is also known as squaring a number. This can be written as A to the power of 2. And remember, this is a power, so it's bumped up a little bit. If it was A times A times A, so A times A times A, A times A times A, this would be written as A to the power of 3. Because there's 3 lots of A's being multiplied together. This gets into index laws, which you'll see a little bit more of in year 9 and year 10. But for now, when you see something like this is A squared. An expression is a combination of numbers and pronumerals combined with mathematical operations. Mathematical operations just meaning plus, minus, divide, which could be used as a fraction line, and multiplication, which is generally a number and a letter put together or 2 letters put together. So for example, 3x plus 2yz, this right here is just an expression. I have no idea what x, y, and z are. There could be some type of context behind it, but for terminology reasons, this is just called an expression. 8 divided by 3a minus 2b plus 41, again, is an expression. Now you'll see the word expression pop up quite a bit, and you'll also see the word equation pop up quite a bit as well. And there is a difference between the two, but for now, all we know is that an expression that looks like this generally does not have an equal sign with it. The last dot point is a term. is part of an expression with only pronumerals, numbers, multiplication, and division involved. So for example, 9a, we have a 9 and an a. This is counted as one term. This 10cd, this is counted as one term. When they're all put together through multiplication, it's considered a term. When they're all put together through a division or a fraction, they're also one term. So this thing right here, if I were to write 3mnt all over 5xy, even though we can see 5 letters and 2 numbers, this whole thing here is all joined together, so it's considered as one term. But when it's not a term is when you have a plus or a minus involved with it. So I could have 6y plus 2x. Right now we have two terms. We have the 6y as one of them, and we have the 2x as another term. They are not held together through a plus or a minus, so be very careful with this. So let's look at a few examples. Here we go. Example 1a. List the individual terms in the expression 4a plus b minus 12c plus 5. Now again, as I stated before, if they're together with a multiplication or a division, they're considered a term. So the individual terms we have here, we have a 4a at the start, we have a b that's by itself, we have a 12c, but there is this negative involved, so we're going to list it as 12c, but with a negative involved. This is very, very important. And this 5 is just like this. Now some answers within the back of the textbook might just have it as 12c without the negative. Technically there should be a negative there because it is an important factor to this expression, whatever it is. But as long as you can grab the individual term of each of these, that's the main skill we're looking for. For b, in the expression 4a plus b minus 12c plus 5, state the coefficients of a, b, c, and d. Now coefficients, fancy word, but all coefficient mean is the number in front of a variable. The number in front of a variable. So the coefficient of a, let's look in this expression here. The number in front of a is 4. So the coefficient of a is 4. The coefficient of b, now a lot of students when they first get introduced to algebra, they tend to think that if a b is by itself, because there's no number in front of it, the coefficient is 0. Now I want you to be very careful. Technically, the coefficient in front of b is 1. Now even though we don't see a 1 in front of it, it is 1. What coefficient technically means is how many lots of a certain variable are there. Because 4a technically means a plus a plus a plus a. This is the same as 4 lots of a. So our coefficient is 4. When it comes to b, our coefficient is just b. How many lots of b are there? Well, there's only 1. So the coefficient of b, how many b's are there, is just 1. Okay, so be very careful of this. The coefficient of c is negative 12. So the number in front of the c is 12. And the coefficient of d, well, there is no d, is there? So the coefficient of d, this is where you can say 0, because there's 0 lots of d's. Question C. What is the constant term in 4a plus b minus 12c plus 5? So the constant term means the number that is by itself without any variable. In this case, it's just 5. There's no variable that's attached to 5, so the constant term is just 5. For D, we're going to state the coefficient of b in this expression here, 3a plus 4ab plus 5b squared plus 7b. Now, the 3a obviously has no involvement, so we can just forget about that. But we can get a bit confused because there is a b within the 4ab and there's a b within 5b squared. We're just looking for the coefficient for b. We're looking for how many lots of just b's there are. So not 4ab, not 5b squared, 7b. So there's 7 lots of b. So coefficient for this expression here, for b, is just 7. We're going to look at one more example, one more set of examples rather. We're going to write an expression for each of the following. Now there are 4 different words that you will see quite a bit. Sum, difference, product, and you will also see a quotient pop up once in a while. You won't see it as much. So sum, product, and difference are the main 3 that you'll see. Sum just means adding. Okay, so sum just means adding. Product, and not to get confused with the product in a store, product just means multiplying. Room there, which is multiplication. And difference, and you hear me say this in class quite a bit. What's the difference between these 2 numbers? This is just subtraction. Which is a minus. Okay. If we use these 3 terms, we'll be using them, or you'll be seeing them within algebra. So this is saying here that we want the sum of 3 and k, and we're going to write an expression for this. The sum of 3 and k. This just means that we're going to add 3 and k. Well, that's just 3 plus k. That's the sum of 3 of k. That's the expression for it. Not too tricky at all. Another way we can write this is k plus 3. Again, the sum of 3 and k can be written as k plus 3. Don't overcomplicate it. Okay, it's actually quite simple. The product of m and 7. Now, there's going to be this new rule that's going to be introduced when to algebra. The product of m and 7. Now, a lot of students will go, oh yeah, that's easy. That's just m times 7. And while this, in the technical term, is true, in algebra world, we don't use a multiplication sign. So, we have to write this as m7. But there's this other special rule within algebra that states that whenever you have a certain amount of a variable, the number or the coefficient will always go in front of this. Coefficient will always go in front of this. So technically, 7m is the correct way of writing the product of m and 7. Okay, if you show this on a test for whatever reason, this is a big no-no. Okay, you have to write it in this form here. Question C, we're going to be looking at 5 is added to 1/2 of k. Now this is going to be a little bit tricky because there's a couple of things going on here. We know that 5 is added to something. So we know that there's going to be this plus 5 that's going to just tag along at the end because 5 is added to something. What it's being added to is 1/2 of k. 1/2 of k. So if I want to get k, obviously there's going to be a k involved. And to get a half of this, we just have to divide this by 2. Yeah? But we're in algebra world, so we can't just write a divide by 2 or use the division symbol. We have to write it like this. K divided by 2, or half of k. Some textbooks sometimes might show it like this. The half with a k next to it, plus 5. Both of them will suffice, that's fine. But if you want to just get used to the terminology of halving or putting it in a fraction form, just stick to this one here. K over 2 plus 5. And again, with the same as A, you can flip this around, so you can do 5 plus k over 2, that's completely fine as well. And the last one, the sum of a and b is doubled. The sum of a and b is doubled. Now we're getting into a little bit of tricky territory, because now we have to introduce brackets, and it's not obvious. It's not obvious. So the sum of a and b is doubled. So we know we have the sum of a and b. That's easy. Now we can just do this. Now this is doubled. And we can't write times 2. Okay? We can put a 2 in the front of it to indicate that it's being multiplied by 2, but the only trouble we get, or we run into, is that this is implying that we're multiplying a by 2 but not b. So the sum of a and b are doubled. This is where we use brackets. This is to indicate that whatever the sum of a and b is, we work this out first, then to double it we multiply by 2, so this 2 tags along in the front. Okay, so it's 2 bracket a plus b, and this will be our final solution. And this is the conclusion of showing you how to approach the questions within 5a. When you get 5a out, it's going to look like this. Now to find this has been left in Compass within the Resources tab under the topic of Algebra. The actual questions itself is on page 291, and what it looks like are these questions here. The type of questions, or the questions that I want you to do, is question 1, question 2, and on the next page, question 3, question 4, and question 5, all left hand side. Okay. You'll have 2 lessons to work on this. If you want to challenge yourself and you found that that was pretty easy, you can attempt question 6, all of question 6. But for now, prioritize question 1, 2, and then 3, 4, 5 left hand side. To give you a bit of closure of where to find these resources, when you head to our class, click on resources, and here you'll see topic 5 algebra as the new folder. In here you'll see chapter 5 algebra PDF version of the textbook, which will show you chapter 5, and there's also this algebra log sheet. This is just an indication of what questions you are going to approach. You don't have to do every single question. This gets determined by me during the class. For now, this is the end of the video. Best of luck with this set work. How you hand this in is just by taking pictures of this and sending it to me via Microsoft Teams via the chat system. If you need any help, you know where I am in the Microsoft Teams chat. Till then, best of luck, and I'll see you either next team meeting or within the next video. Bye bye.